Picture this, a swirling cloud of gas and dust, remnants of a supernova long gone. This cloud, known as a nebula, is the birthplace of stars and planets. It's a chaotic and beautiful nursery where the seeds of solar systems are sown. This is the beginning of our story, the birth of our solar system. In this vast expanse, tiny particles begin to collide and stick together, forming clumps that grow larger over time. Gravity, the architect of the cosmos, slowly draws these particles together. It's a delicate dance, where every particle plays a role in the grand design. Over eons, the cloud collapses in on itself, spinning faster and faster. This rotation causes the cloud to flatten into a disk, with most of the material gathering at the center. At its heart, a star ignites, our very own sun, a brilliant ball of nuclear fire. This ignition marks the birth of a new star, a beacon of light in the darkness of space. As the young sun blazed to life, it pushed away some of the surrounding gas and dust with its powerful solar wind. This wind is a stream of charged particles that sweeps through the solar system. However, gravity held on to the rest. The remaining material, bound by the sun's gravitational pull, began to coalesce into a swirling disk. This remaining material, a swirling disk of cosmic debris, would become the building blocks of our planet. This disk, known as a protoplanetary disk, is where planets, moons, and other celestial bodies are born. Imagine a chaotic ballet of collisions, smaller rocks smashing into each other, their remnants merging to form larger ones. These collisions are violent and frequent, shaping the future planets. This process, known as accretion, gradually built up the Earth we know and love. Over millions of years, these collisions and mergers formed a growing planet. It was a violent and fiery birth. The young Earth was a molten inferno, its surface constantly reshaped by volcanic activity and impacts from space debris. The young Earth was a molten inferno, bombarded by asteroids and comets. These impacts brought not only destruction, but also essential elements and compounds that would later be crucial for life. It's hard to imagine that this hostile environment would one day give rise to life. The early Earth was barren and fiery, a far cry from the blue and green planet we know today. But the universe works in mysterious ways. Through a series of fortunate events and natural processes, the stage was set for the emergence of life. Over time, the bombardment slowed and the Earth began to cool. This cooling allowed the molten surface to solidify, forming a stable crust. The molten surface solidified, forming the first crust. This crust was the foundation upon which continents and oceans would eventually form. This was a pivotal moment, the first step towards a habitable planet. With a solid surface, the Earth could begin to support the complex processes that would lead to life. But Earth's story was far from over. It had just begun. The planet would continue to evolve, setting the stage for the incredible diversity of life that we see today. From its fiery beginnings to the lush, vibrant world we inhabit, Earth's journey is a testament to the wonders of the universe. While the young Earth cooled, a dramatic event unfolded in its cosmic neighborhood. The early Earth, still a molten and turbulent world, was about to experience a cataclysmic event that would forever alter its destiny. A Mars-sized object, which we call Theia, slammed into the Earth with unimaginable force. This colossal impact was not just a simple collision, it was a cosmic event of epic proportions. Imagine the cataclysm, the sheer energy released in this collision. The impact was so powerful that it vaporized a significant portion of both Theia and the Earth's crust, sending debris hurtling into space. It was a defining moment in Earth's history, an event that would shape its destiny. The collision not only altered the physical structure of our planet, but also set the stage for the formation of a new celestial body. The impact sent shockwaves through the young planet, melting its surface and blasting molten rock into space. This molten material, mixed with fragments of Theia, formed a vast cloud of debris orbiting the Earth. This debris, caught in Earth's gravitational pull, slowly coalesced, forming a ring around our planet. Over time, the particles within this ring began to clump together, gradually forming larger and larger bodies. This ring, over time, became our moon. The process of accretion, where particles stick together and form larger masses, eventually led to the creation of a single large body that we now know as the Moon. The Moon's gravitational pull stabilized Earth's axial tilt, preventing drastic climate swings. This stabilization was crucial for the development of a stable climate, which in turn was essential for the evolution of life. It also created tides, which played a crucial role in the development of life. The rhythmic rise and fall of the tides influenced the early marine environments, creating diverse habitats where life could thrive. The moon, our celestial companion, is more than just a pretty face in the night sky. Its presence has had profound effects on the Earth, influencing everything from the length of our days to the behavior of the oceans. It is a silent guardian, a vital part of what makes Earth so special. Without the moon, our planet would be a very different place, with a more chaotic climate and less stable conditions for life. This early Earth-Moon system was a sight to behold. The young moon, glowing brightly in the sky, was much closer to Earth than it is today, exerting a stronger gravitational pull. The young moon, much closer to Earth than it is today, dominated the sky. Its proximity meant that it appeared much larger in the sky, casting a significant influence on the planet below. Its gravitational pull created powerful tides, shaping the early oceans. These tides were much more extreme than those we experience today, constantly reshaping the coastlines and influencing the development of early marine life. It was a time of great change, a time when Earth was still finding its footing. The planet was undergoing rapid transformations, with volcanic activity, shifting continents, and the gradual cooling of its surface. The moon's formation was a defining moment in Earth's history. It not only influenced the physical characteristics of our planet, but also played a crucial role in the development of life. It set the stage for the emergence of life, paving the way for the remarkable journey that would unfold over the next 4 billion years. The moon's presence has been a constant companion throughout Earth's history, guiding and shaping the evolution of life on our planet. As Earth cooled, something truly magical happened. Water vapor trapped deep within the planet's interior began to escape through volcanic vents. Imagine the scene, a fiery landscape shrouded in thick steam as volcanic eruptions spewed gases and water vapor into the atmosphere. This was the birth of Earth's very first oceans. Over millions of years, the water vapor condensed, forming thick clouds that blanketed the planet. Torrential rains lashed the Earth's surface, filling the first basins and creating vast shallow seas. These early oceans were not the serene blue waters we are familiar with today. They were a primordial soup, rich in dissolved minerals and gases, a chemical playground ripe for the emergence of life. These oceans, teeming with the building blocks of life, were bathed in energy from the young, vibrant sun. Lightning crackled through the atmosphere, providing further energy to this chemical cauldron. The stage was set, the ingredients were in place. All that was needed was a spark to ignite the process. The origin of life remains one of the most profound mysteries in science. It is a question that has intrigued and puzzled humanity for centuries, driving countless scientific inquiries and philosophical debates. How did life arise from non-living matter? This enigma has led scientists to explore the very foundations of chemistry and biology, seeking to understand the processes that could have sparked the first living organisms. It's a question that has captivated scientists for centuries. From the early natural philosophers to modern-day researchers, the quest to uncover the origins of life has been a driving force in the advancement of science. While we don't have all the answers, we do know that around 3.8 billion years ago, in those primordial oceans, something extraordinary happened. Life emerged. The conditions on early Earth were harsh, with volcanic activity, lightning storms, and a tumultuous atmosphere. Yet somehow, these conditions set the stage for the birth of life. The first life forms were simple, single-celled organisms, far simpler than even the most basic bacteria alive today. These primitive entities were the building blocks of all life, the first step in a long and complex journey of evolution. But they possessed the spark of life, the ability to replicate and pass on their genetic information. This ability to reproduce and transmit genetic material was crucial, as it allowed life to persist and evolve over generations. They were the pioneers, the first inhabitants of our planet. These early microorganisms were the trailblazers, venturing into a world that was still in its infancy. These early microorganisms thrived in the nutrient-rich oceans. The primordial soup provided a rich environment, teeming with the raw materials needed for life to flourish. They absorbed energy from the sun, utilizing it to build complex molecules and replicate. This process, known as photosynthesis, was a game-changer, allowing these organisms to harness solar energy and convert it into chemical energy. They were simple, yet they possessed the most remarkable ability of all, the ability to evolve. Through countless generations, these microorganisms adapted to their environment, developing new traits and capabilities. Over millions of years, these early life forms diversified, evolving and adapting to their environment. This diversification led to an incredible variety of life forms, each uniquely suited to their ecological niche. They spread throughout the oceans, their numbers exploding. The oceans became a vast interconnected web of life, with microorganisms playing a crucial role in the planet's ecosystems. They were the architects of Earth's biosphere, laying the foundation for all life that would follow. These early life forms created the conditions necessary for more complex organisms to evolve, setting the stage for the incredible diversity of life we see today. Their emergence marked a turning point in Earth's history, the transition from a geological world to a biological one. This transformation was profound, as it signaled the beginning of a dynamic and ever-changing biosphere, teeming with life in all its forms.